13.3, evaluate trig functions of any angle. Okay, and there are a lot of notes that go with this section. So the general definition of trig functions. Let theta be an angle in standard position and let xy, what is going on right now? Okay. And let xy be the point where the terminal side of theta intersects the circle x squared plus y squared is equal to r squared. The 6 trig functions are, this thing is being really weird right now and I don't know what's going on. 6 trig functions are sine of theta, well, here, let's draw the circle first over here for reference. Look at that, it made me a nice circle. Okay, this is the point xy. This is angle theta. Y and x. Okay, so the 6 trig functions, sine of theta is y over r. Cosine of theta is x over r. Tangent of theta is y over x, assuming x is not equal to 0. Okay, now r is not going to be 0, so that's why we don't have to worry about that with the other ones, but with the tangent, we do have to worry about x could potentially be 0. Let's see, cosecant of theta, r over y, so y is not equal to 0. Secant of theta is r over x for x not equal to 0, and cotangent of theta is x over y for y not equal to 0. Sometimes these functions are called circular functions. Okay, so that's just some general stuff you need to know. Basically, a lot of this section you'll be given a point, and you have to, on the terminal side, and you have to find the trig functions based on the given point on the graph. So hopefully you all know how to graph a point, because that's very important. Okay, now the unit circle is next, okay, and I've mentioned this several times. We've already looked a little bit at it, and we're going to get a lot more in depth with it here in this section. But the unit circle definition, let's change up the color here a little bit. So the unit circle, move this up here. The circle x squared plus y squared is equal to 1, which has center 0, 0, and radius 1 is called the unit circle. Okay, so the radius is 1, and it has to be centered at 0, 0. Okay, otherwise it's not a unit circle. The values of sine of theta and cosine of theta are simply the y-coordinate and the x-coordinate, respectively. Okay, so y goes with sine, x goes with cosine. Those are big things to remember. Of the point where the terminal side of theta intersects the unit circle. Okay, so a little picture of this over here. Let's see if it'll draw me a nice circle again. Oh, it did. Sweet. So really doesn't matter where I draw this stuff. I'm just going to draw it this way. This is the point xy. The radius is equal to 1. Then we've got theta here is the angle. So the sine of theta is equal to y over r, which is y over 1, or just y, and the cosine of theta, so this is just explaining why it is what it is, so x over r is x over 1, which is equal to x. So hopefully that helps you kind of see where that's coming from. It's like the same color I'm already using. Let's just go purple. So then we have another definition. A quadrantal angle is an angle in standard position whose terminal side lies on an axis. Okay, so either the x or the y axis. It is always a multiple of 90 degrees or pi over 2 radians. Okay, the next thing is reference angle relationships. So theta is an angle in standard position the reference angle for theta is the acute angle theta, formed by the terminal side of theta and the x-axis, the relationship between theta and theta prime. Oh, also this angle theta, the acute angle, this should be theta prime. Or with a little, it's called prime, but it's with a little apostrophe on it. Okay. So the relationship between theta and theta prime will be shown below for non-quadrantal angles theta such that 90 degrees is less than theta is less than 360 degrees, or that pi over 2 is less than theta less than 2 pi, okay, if we were to do it in radians. So I'm going to show this here. You need to have 3 quadrant things drawn. Okay, quadrant 1 is easy, so we don't even have to deal with it. Okay, so let's see. This is going to be quadrant 2, quadrant 3, and quadrant 4. And so we are going to have, I'm going to go ahead and just draw in each of these little angles here. Oh, I already had orange. So I'm going to draw them in. Theta. Theta again. And all the way back around. Theta here. Okay. So then the reference angle that I'm referring to here is, try to find a color that's pretty different. Purple, hopefully that one's sufficient. So the theta prime is this area here, okay, our acute angle, and it's always with the x-axis. Okay, we're always going to do it with the x-axis. It's not with the y-axis. So it's always going to be touching the x. That's how we get it. So I'm going to do degrees and radians for both. Okay, all the way across it's going to be that. So for degrees, okay, theta prime is equal to 180 degrees minus theta. Excuse me. For radians, theta prime is pi minus theta. Okay, quadrant 3 again, I'm doing degrees on top, radians on the bottom. Theta prime is theta minus 180 degrees. For radians, theta is theta minus, or sorry, these are theta primes here. Theta minus pi. And then for quadrant 4, theta prime is 360 minus theta. For radians, theta prime is 2 pi minus theta. Okay, so that's how you find the reference angle, and obviously we'll do plenty of examples for this to make more sense, because right now you're just looking at a whole bunch of formulas that you probably have no idea what they mean. And let's see, I think we're to the last little notes thing here. You're going to need a pretty good amount of space for this. I think everything else that I have written down that I was going to go over is just examples, so we will do it, yeah, we'll do those in class, obviously. So, the last thing here is evaluating trig functions. Okay, so steps to evaluate trig functions for any angle theta. So I'm going to have 3 steps. So the first one, find the reference angle theta. Okay, and you're going to also, just really quick, you're going to need to leave a good amount of space over here. Okay, for a coordinate plane, where we're going to write in the signs of function values. Okay, and what happens in each quadrant, so just make sure you leave space over there when you're writing your steps. So first, find reference angle theta, then theta prime. Dear goodness, I keep forgetting to write the prime. Evaluate the trig function. For theta prime. And then the last step, determine the sign of the trig function value from the quadrant in which theta lies. So we're going to fill in the sign values, okay, for each quadrant. So quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, so in quadrant 1, sine of theta and cosecant of theta are positive. Okay, so I'm going to put it with its buddy. Okay, cosine of theta and secant of theta are positive, and then tangent of theta and cotangent of theta are positive. Okay, so in quadrant 1, x and y are both positive, so everything is positive. Okay. Quadrant 2, sine of theta and cosecant of theta are positive, okay, because my y values are still positive. Okay. However, cosine of theta and secant of theta are negative because my x values are now negative. Okay. Cotangent of theta and tangent of theta, I have these written backwards. Let me reorder these. Tangent of theta and cotangent of theta are also negative, okay, because if one of them is negative, then that's going to make tangent and cotangent negative. In quadrant 3, sine of theta and cosecant of theta are both negative, okay. Cosine of theta, secant of theta is negative, and then tangent of theta and cotangent of theta, because x and y are both negative, that makes them positive. Okay, and I can do a walkthrough and explain how I'm getting these better in class, so somebody just remind me of that. In quadrant 4, sine of theta and cosecant of theta are negative. Cosine of theta and secant of theta are positive. And then tangent of theta and cotangent of theta are negative. Okay, So this just has to deal with the signs of x and y and how we get those. That is all for the notes for this. So I'll scroll back down so that way you guys can see that. But that's all for this section of